Hey guys, so this video is just going over kind of quickly our bell questions from this week so far. This will be Monday, Tuesday, Wednesday, and Thursday for the week of December 7th. Okay, so what I have for you are each day's bell work and just kind of a brief explanation of the answer for this. If you did struggle, if you do still have questions after this video, please email me. Happy to explain further. So I'm going to get rid of my little webcam here because I'm looking at my other screen. So Monday's bell work is pick out a piece of clothing you're currently wearing. Would this be a better insulator or conductor, and why? So I had a lot of students mention things like hoodies, maybe jeans, coat, t-shirt, tank top, whatnot. So if we look at our hoodie or if we look at a coat, those are better insulators because they are really good at resisting the flow of thermal energy. So they'd be a really good insulator. If you have a really nice down jacket, they're expensive because generally they work really well. These feathers tend to trap air between the particles or between the little veins of the feather. And that is what makes this a better insulator. Things like jeans are also good insulators. But then we start talking about what would make a good conductor. Things that expose your skin to the air allow for your heat to escape, your body heat, that is. So in the summertime, we're used to seeing things, pieces of clothing that really reveal a lot of your skin. Your skin is a great conductor. And keep in mind, mammals do have body hair that covers all of their body. However, it's not enough, right? So a dog or a cat or a horse or a cow, think of any mammal, they generally will have enough hair on their body where they stay plenty warm. Humans, though, for instance, we need some covering. That's where clothing originally came from. Just keep in mind, if we look at this GIF right here, it's showing that here's our heat source. And then as this heat source stays beside this material right here, it's allowing those particles to heat up quickly and easily. This substance that's made out of these particles is allowing these particles to move. That's why this is showing a really good conductor. An insulator would resist the movement of its particles, and that heat would not be able to travel through that object easily. Okay. Let's look at Tuesday. Why is a melting ice cube an endothermic reaction? So we see our ice cube melting. Let me change back to my laser pointer. We see our ice cube melting. So our endothermic reaction, this ice cube will be soaking in heat from the surroundings, causing the ice cube to melt. The ice cube will be soaking in that heat, therefore it is an endothermic reaction. Remember, with an endothermic reaction, I like to think the heat goes into the reaction. Okay. Wednesday, when you dissolve ammonium chloride in water, a chemical reaction occurs. You just have to explain if it's an endo or exothermic reaction. So at the time of 0, we're going to assume that there's two substances. You throw them into a beaker, maybe stir them up, and then this happened. So right when the two substances, the water and ammonium chloride, were mixed, we start right here at time 0. As we move and follow this line, time is continuing on. My question for you is, in general, though, in this whole graph, from the start to the end, did temperature increase or did temperature decrease? That is the question. Did this substance get warmer or colder over time? At the start, we were at 5 minutes, or I'm sorry, at 5 degrees Celsius, and at the end, we were at 3.5 degrees Celsius. The temperature decrease, meaning that this is an endothermic reaction. It got colder. Okay. I will continue on with Thursday's spell work with a separate video.